Hi guys, very good evening. Welcome to Grade Up, India's largest live learning platform. So today we are going to have a very good session on this digital logic in the topic synchronous sequential circuits. So we'll discuss what is a sequential circuit, how to design the synchronous sequential circuits, what are the flip-flops we are using in those circuits. So these things we are going to discuss, and please join quickly. And so we are just about to start the session. And before that, please confirm me once whether my audio, video, everything is fine. Every one of you, please. Yes, please confirm me once whether my audio, video, everything is fine. Yes, Sham. Good evening. Under the 25 most important topics of our GATE 2021, so this is our 24th topic. So that is synchronous sequential circuits. Yes. So before we start this session, so every one of you, please confirm me whether my audio, video, everything is fine. Okay. So now, before starting of the session, okay, so let me introduce myself because some of you may be new to this session. So just I will give introduction about myself, and before that, you can just subscribe to this channel. So more than 3 lakhs 12,000 students are having subscription for this YouTube channel of GATE for the grade up, right? So and also you can like the session if you are really liking it, and you can share with your friends, so any of your friends, you can share this channel and also this details of this YouTube channel and let them subscribe and like this. Okay. So now before starting of the session, so let me introduce myself. Myself Murali Krishna. I'm having 20 years of teaching experience both in the GATE teaching and also I worked in different engineering colleges. And I'm topper in one of the NPTEL course that is in the subject theory of computation, and I stood top in the exam with 96% of marks, and I am certified as International Engineering Educator through the IZIP certification program, and also qualified in the GATE exam, and have trained more than 50,000 students across the country in different core areas of computer science and engineering. So those are the theory of computation, that is a TOC, and operating systems, that is OS, computer organization and architecture, COA, computer networks, CN, and digital logic design, DLD. So these are the a few subjects where I am familiar with. So this is about my brief profile. So now let us go to the topic. Okay, so before that, so I request every one of you to please subscribe to this YouTube channel, GradeUp's Gate YouTube channel, and like the channel, and also you can like the session. Okay, and share with your friends. And I'm just forwarding you the link to follow me in the GradeUp app. You can just follow me in the GradeUp app so that you will get more notifications related to my classes in the GradeUp app. Okay, so regularly we are giving some free classes, so you can use this channel so that if you follow me, you can get notifications related to my classes. You can just now I have forwarded my link. You can just follow me. Okay, so now let us begin the session. So quickly join, and we are having more topics, and the time limit is around 50 minutes. So please try to understand. Okay. So first of all, what is a sequential circuit? Okay, a sequential circuit is nothing but it is a combination of logic gates and also the flip flops. Okay, so here memory indicates the flip flops. So what do you mean by flip flop? Flip flop is nothing but it is a binary storage cell. Okay, which is capable of storing one bit of information. Okay, so in total in a sequential circuit we can have different inputs and different outputs. Yes, Akshay Kumar, hi. How are you, Akshay Kumar? Very good evening. Okay. So now a combinational circuit is a corrected arrangement of logic gates, and there can be some inputs and also some outputs. And some outputs of the combination circuit we can give as input to the memory elements. Those are flip-flops, and also they are connected with the clock signals. And outputs of the flip-flops can be given for input to the combinational logic circuit. So this will form a sequential circuit. So only combination circuit will have just like this. Okay. So different arrangement of logic gates, and then we can have some set of inputs and some set of outputs. So this is the connected arrangement of logic gates is the combinational circuit. But when you are adding the flip-flops, so flip-flop is nothing but it's a binary storage cell. So some of the outputs can be connected as input to the flip-flops and also some clock input, and outputs of flip-flop can be connected as an input to the combination circuit, feedback connection. So this type of circuits are called sequential logic circuits. Sequential logic circuits. I hope you are understanding. Okay. So now this is about the block diagram only. So I am not shown you any of the design of any of the particular circuit. So counters, registers, okay, and shift registers, normal registers, okay, and up counter, down counter. All these circuits are sequential circuits. They are made up of different flip-flops. Okay. So quickly you can join and don't leave the session till the end. So this is very useful session. And as far as the digital logic is concerned, out of this series, this is the last session for the digital logic. So we planned for 3 sessions. One we have finished with the number system representation, and other we have finished with the topic called combination circuit. Okay, representation of numbers and logic minimization of logic functions. Then it is a sequential circuit. Next. Okay. So please join quickly. Don't wait further more, and you can. Yes. Okay. And please stay in the session till the end. So that is what very much important here. Okay. Now coming to the next. What is a flip flop? Okay, because we are using the flip flop. A flip flop is nothing but it is a binary storage cell. So it can be, you may have D flip flop or SR flip flop, T flip flop, JK flip flop. You may have different types of flip flop. Okay. So but what is required, I am telling you. Okay. So we can have a clock input. Depends on the type of inputs. We can have flip flop inputs also, maybe one input or multiple inputs. So we have to give some inputs to the flip flop, and it will represent with the states like present state of the flip flop and then complementary state of the flip flop. Present state indicates what is the value of that, whether it is 0 or 1. If the flip flop value is 0, for example, the state indicates 0, and q bar indicates the complement of the present state. So if it is 0, it will show it is 1. If it is 1, it will show as a 0. So that is a normal state and complementary state. So the inputs will have an effect only in the presence of clock pulse. Flip-flop inputs will have an effect only in the presence of clock pulse. It can store either 0 or 1. So 0 indicates it is a low state and 1 indicates it is a high state. 0 indicates low state and 1 indicates high state. Okay, now usually the states of flip-flop are represented like this. Q of t is nothing but state of the flip-flop at time t, so it indicates the present state. It indicates the present state. State of the flip-flop at time t, that is nothing but it is a present state. Okay, Q of t plus 1 indicates the state of the flip-flop after applying inputs, so that is called the next state. That is called the next state. Okay, flip-flop inputs is important to decide what is the next state. Okay, and flip-flop input, what input you are giving, how many inputs you are giving, that depends on the different types of flip-flop. Okay, so we are having wide variety of flip-flops actually basically, and we use in design of sequential circuits. So these three are widely used. One is the D flip-flop. We use JK flip-flop are used. D flip-flop is used, and JK flip-flops are used, and also T flip-flop. JK flip-flop and T flip-flop. So these are the three categories of flip-flops exactly. JK flip-flop and T flip-flop. So T meant for toggle. So three flip-flops we have. So which are used for the design of combination circuit. Yes, Sahil. Very good evening. Happy to see all of you once again. Okay, now the D indicates the data. There is only one input for this, and JK indicates two inputs, and T also will have one input. Okay. So in the presence of clock pulse, so you know the computer generates some clock pulses, master clock pulse generator. So these are the train of clock pulses. In the presence of clock pulses, inputs are having effect. That means output depends on the input in the presence of clock pulse. So clock pulse is the rising edge and it is a falling edge, and this is a rising edge and it is a falling edge. This is positive cycle. From here to here, it is a clock cycle. It's a positive cycle from first positive transition to next positive transition. It's a positive edge triggering. And from first negative transition to next negative transition is a negative edge triggering. So 0 to 1 or 1 to 0, the pulses are being changed. Okay, some flip flops will have an effect when the pulse is going from 0 to 1. Some flip flops will have an effect when the pulse is going from 1 to 0. Clock pulse is going from 1 to 0. That means negative edging and positive edging. 0 to 1 indicates a positive edging and 1 to 0 indicates negative edging. Yes. Chandra, good evening. Okay, now, so I will just describe because in the sequential circuit design, we are going to use the flip-flops. I will tell you the each category of flip-flops. What is a function table of the flip-flop? So function table is simply a characteristic table and also the excitation table. Characteristic table of flip-flop indicates for what inputs, what will be the next state of flip-flop. So as I told you, for example, present state of the flip-flop is 0 or 1. It is only one cell. Either it can store 0 or it can store 1. Okay. So the next state, that is a q of t plus 1, depends on the inputs you are applying in the presence of clock pulse. In the presence of clock pulse. So it's irrespective of the present state, whether the present state is 0 or 1, what input you are giving is important. Okay, so that will decide what is the next state of the flip flop. So q of t indicates present state, what is there inside right now, and q of t plus 1 next state, what happens after applying inputs in the presence of clock pulse. I hope you understood. Okay, so this is what is a flip flop basic functionality, right? So the basic logic. Okay, so if that is known to you, that is sufficient. Now coming to the JK flip flop. Okay, so JK flip flop is having two inputs. One is a J input, other is a K input. J will act as a set and K will act as a reset. Reset is nothing but clearing to 0. Set is nothing but making the flip flop value as 1. And this is the present state. This is a complemented state. So there is a clock input also is present. So clock input is also present. Okay. So JK flip flop functionality, I'll just tell you by means of characteristic table. So the characteristic of JK flip flop is like this. Please note down. Characteristic of JK flip flop. Characteristic table of JK flip flop. So in a JK flip flop, the characteristic table is like in the presence of clock pulse. Say for example, I am giving two things here. One is the clock. Other thing is inputs to the flip flop. So that is a J input and K input. So for certain values of J input and K input, what is the next state? So that is a Q of T plus 1. So that is what is we are going to write here. Okay, I hope you are understanding. If you have any doubt at any point of time, you could ask me. Okay, and you are free to ask, and even after the session is over, so in the comment box you can continue asking the doubts. Okay, and I will reply to all your doubts. Now Q of T plus 1 is the next state. So what happens for each of the cases? This is a characteristic table. So if a clock is 0, not present, inputs are don't care. So it doesn't matter whatever is the input you are giving. So there won't be any effect on the next state of the flip flop. Okay. So in the presence of clock pulse, that means clock pulse is in rising edge. Okay. If a J input, K input are both are 0, next state is equal to the previous state. So that is nothing but no change. There is no change. And in the presence of clock pulse, if the J input, K inputs are 0, 1 for example, so set input is 0, reset input is 1, so that we are going to reset. So this is nothing but clear to 0. It is a clear. Okay. Now when J input is 1, K input is 0, so this is set to 1. The next state of the flip flop is 1 irrespective of the previous state. Okay. In the presence of clock pulse, if J input, K input both are 1s, so this is a complement. So that is a Q bar of T. Q bar of T means complement of the present state. Next state is equal to the complement of the present state. So these are the different entities in the characteristic table. So for instance, I will tell you what exactly happens in the characteristic table. Okay, so this is set and reset. So S indicates set and this is indicate reset. So Q bar, what do you mean by Q bar? It is a complement. So Q bar indicates a complement of the present state. Complement of the present state, exactly. Okay. So then, for example, if you are taking J input, K input 1. So now I will show you excitation table also. So the difference between excitation table and characteristic table, I'll tell you. So let us suppose in the characteristic table, let us suppose JK flip flop is containing value 0 in the presence of clock pulse. J input, K input both are 0. Next state will be 0 only, no change. For example, if present state is 1 and J input, K input both you are giving zeros, and next state will be 1 only. There won't be any change. That's the meaning. Okay. Similarly, if present state is 0 and J input you are giving 0, and k input you are giving 1, that means you are resetting. Resetting means next state is also 0, because present state is not a matter here. Okay. Similarly, if the present state of the flip flop is 1 and you are giving the j input as 0, j input as 1 and k input as 0, for example, j input as 1 and k input as 0. So what happens? The next state will be set to 1. Just a moment. All possible combinations I will show you. So first, in the case of set value 0, reset value 1, that means j input 0, k input 1, and flip flop content 0 means next state will be clear only. So same thing, 0, 1. If a present state is 1, next state will be reset. That means 0. Okay. Similarly, if the present state is 0 and you are giving set input as 1, reset input as 0, so it will be set to 1, irrespective of the present state. If the present state is 1 and set input is 1 and reset input is 0, so that it is set to 1. Next state will be 1 only. Okay. Similarly, you are taking present state as 0 and both j input, k input you are giving as 1, then next state will be complement. Okay. And if the present state is 1 and you are giving j input, k input as 1, 1, next state will be complement of the present state. So this is what the possibilities for different values of j and k inputs, right? Now you can easily understand the excitation table. So what do you mean by excitation table? Excitation table is nothing but a prediction of inputs. Excitation table represents a prediction of inputs for certain changes in the flip-flop. So for example, you are moving from 0 to 0, what happens? 0 to 1, what happens? Those things. So if a present state is q of t and the next state is q of t plus 1, okay, maybe like you are moving from 0 to 0, 1 to 1, 0 to 0, 1 to 0, all the combinations. What might be the j input? What might be the k input? You have to predict. So that is nothing but excitation table. That is nothing but excitation table. I hope everyone of you are following. Is it clear? Please respond once, and don't forget to subscribe to the channel and also like the class. Subscribe to and also share with your friends. Okay. So please quickly. Okay. Fine. And don't leave from the session till the end. Now, for example, if a combinations are taken, present state may be 0, next state may be 0. If the present state is 0, next state may be 1. These are the possibilities. If a present state is 1, next state may be 0. If a present state is 1, next state may be 1. These are the possibilities. If a present state is 0, next state is 0. So these are the things now. So what are the flip-flop inputs? If present state is 0, next state is also 0. Okay, there are two cases for that. One is a 0, 0, other is a 0, 1. So 0, 0, 0, 1 means what? So j input and k input. 0, 0, 0, 1 means it's a 0, don't care. So j inputs can be 0 because k input can be either 0 or 1. So this is nothing but 0 or 1 means don't care. 0, don't care. Next 0, 1. What are the possibilities for 0, 1? So we are going from 0 to 1 here. 0 to 1 means 1, 0. Set value. It may be set to 1. Okay, 0 to 1 it may be complemented also. So it is a 1, 0, 1, 1. So 1, 0, 1, 1 is nothing but it is a 1, don't care. This is a 1, don't care. Next is 1, 0. Hope you are understanding. Okay. So 1, 0. Moving from 1 to 0. 1 to 0, what are the possibilities? This is one possibility. So 0, 1 is one possibility. 1 to 0 to move, 1, 1 of j and k inputs are one possibility. So 0, 1, j input, k input, 1, 1. So that is nothing but don't care 1. Don't care 1 are the j and k inputs. So we are just predicting the values of inputs for certain changes in the flip-flop from present to the next state. Is it clear? Are you following? So please respond here in the chat box whether you are following or not. If not, if you have any doubt, you could ask me once. Okay, please don't leave from the session. Okay, and 1, 1. Yes. Thank you for your response. Okay, 1, 1 means previous state is 1, next state is also 1. 1, 1 possibilities are this one. We are moving from 1 to 1 here, and also we are moving from 1 to 1 here. So this means for 1, 0 case, 0, 0 case, 0, 0, 1, 0. So that is nothing but don't care 0. So don't care 0. So this is the excitation table of JK flip-flop. This is the characteristic table. What makes the difference between characteristic table and excitation table? In the characteristic table, we will just decide what will be the next state for certain inputs in the presence of clock pulse. In the excitation table, we are going to explore the prediction of inputs for certain changes in the states, like from 0 to 0, if it changes, what happens, 0 to 1, if it changes, what happens, 1 to 0, what happens, like this. Hope you understand. Okay. So please like the class and subscribe the channel. Don't forget this, and also share with your friends. Okay. So now that is excitation table. Now coming to the next, D flip flop. So D flip flop is also only one input is there. So this indicates the data. So whatever is input, next state is equal to the D input. That's all. That's the D flip flop logic. Okay, in the JK flip flop, J input, K inputs are zeros, then no change of state. 0 1 means reset, and 1 0 means set to 1, 1 1 means complementing. So D input is just whatever is irrespective of the previous value, next state is equal to the D input. That's all. So characteristic is very simple. It will be like this for the D flip flop. So this is a clock and D input, and what is the next state? Next state is nothing but q of t plus 1. So most of the registers design is done through the D flip flop only. Most of the registers design, so for parallel loading of the data, we use a D flip flop. Okay, for some counters we use either JK flip flop or the T flip flop. Okay. Okay, now when the clock is 0, D input is don't care, output will be 0 always. When the clock is present, if D input is 0, next state will be 0. If D input is 1, next state will be 1. Just it is equal to the D input. That's all. That means loading the data into register. Whatever the data you wanted to load, you could load that. Okay. Now excitation table is also very simple for this. Excitation table is also very simple for this. So what is excitation table meaning? So if the present state is q of t and next state is q of t plus 1, okay, and what will be the D input? So we know that in a D flip flop, D input next state is equal to D input like this. So q of t plus 1 means what? It is the next state after applying inputs is equal to D. Whatever is the D, the next state is same. If D is 0, next state is 0. If D is 1, next state will be 1. Hope you are understanding. Is it clear? So please like the class. Don't forget to subscribe the channel. So I'll give you just 2 seconds of time. I'll just wait. Please do that. Finish that first. Every one of you, please subscribe the channel. The main advantage of that is you can get different notifications related to the classes. Okay. So please do that. And I am forwarding my link. If you have not followed me in the GradeUp app, you can just follow me. You will get notifications related to the free classes. Okay. Now, in the present state is 0, next state is 0, for example, then obviously D input should have been 0. If present state is 0, next state is 1 means definitely D input should have been 1. That's why next state became 1. If the present state is 1, next state 0 means D input should have been 0. That's why next state became 0. Okay, if the present state is 1, next state is 1, D input should have been 1, that's why it has become 1. So like that we can take it. So this is the excitation table of D flip flop. So these are used in the, yes, exactly. Where these are used? In the design of registers. Hope you are understanding. Okay. Now coming to this next flip flop, T flip flop. T meant for is a toggle. So T is meant for toggle. So what do you mean by toggle? So toggle is nothing but it is something like, let us suppose you are giving T input as 0. Next state output will be as it is, no change of. It is equivalent to the present state. Okay. If a T input is 1, output is complement of the input. Okay, like this. Okay, so for example, exit characteristic table I am looking at here. So clock input and T, and what is the next? Q of T plus 1. Q of T plus 1 indicates the next state of the flip flop. Q of T plus 1 is the next state of the flip flop. Hope everyone of you are following. Okay. For example, in the absence of clock pulse, T doesn't matter. Okay, no effect. In the presence of clock pulse, if T value is 0, next state is as it is, no change. Q of T. In the presence of clock pulse, if T value is 1, so this indicates complement. So Q bar of T. Next state is equal to complement of the present state. Next state is equal to complement of the present state. Hope you are following. Is it clear? Please respond. Every one of you, please. Okay, so now coming to this excitation table. Excitation table. Excitation table, as you know, we have to take some inputs. For example, I am taking present state is q of t and next state is q of t plus 1. So what should be the t input? What should be the t input? That is a prediction of t input based on the changes. For example, you are moving from 0 to 0. So your next state is 0 means the t input should have been 0. 0 to 1 means next state is complement of the previous state. So t input should have been 1. Yes. Thank you, Akshay. Okay. And if the present state is 1, next state 0 means definitely it is complemented. T input 1, then only it would be complemented. If present state is 1, next state 1 means there is no change. It is the same as the previous state. So that the T input should have been 0. So this is excitation table. And there is one equation here. Next state of the flip-flop T is equal to exclusive OR operation between Q of T and T. Exclusive OR between Q of T and T. What is exclusive OR? Say for example, you are taking 0 exclusive OR 0, it is 0. 0 exclusive OR 1, you are getting 1. 1 exclusive OR 1, you are getting 0. 1 exclusive OR 0, you are getting 1. Like this. That is exclusive OR operation. Okay, so hope you are following. Okay, this is about T flip-flop, toggle. Okay, now coming to the design of 2-bit up counter using JK flip-flop. Okay, so quickly I will explain so that the synchronous circuit means, what do you mean by synchronous here? If all the flip-flops are affected at discrete intervals of time, so that is nothing but synchronous. Okay, at the same time, all flip-flops will be having an effect, and at a synchronously all the flip-flops at the same time. But whereas in the case of the asynchronous, so the flip-flops may get at any time. So with the effect of output of one flip-flop, the clock will be applied to the next flip-flop. A pulse given to the next flip-flop is output of one flip-flop, so the delay will be more in asynchronous. In asynchronous, all the flip-flops are connected to the common clock pulse. So that makes the difference between synchronous and asynchronous. Okay. Now I wanted to design a 2-bit binary up counter using the JK flip-flop. So you know JK flip-flop functionality and excitation table also required for it. Okay. So this is a very important design. Okay. So 2-bit up counter means, let us suppose if the present state of the 2-bit flip-flops are 0 0 for example. Okay. Next state should be 0 1 if count is enabled. Next state should be 1 0. Next state should be 1 1. Again it has to go back to 0 0. So for example, if I am taking this as S0, S1, S2 and S3, these are the states. Then from S0 to S1 it should go up counting. Next 1 0, next 1 1, next 0 0. It has to go back to 0 0 and repeat. If it is a 3 bits, we can give maximum 2 power 3 possibilities. That is 8 different count sequence will come. Okay. So now as we are taking 2 bits means 1 bit is held by one flip flop, right? So 2 JK flip flop we have to take. Let us say A and B are the flip flops. So let us take present state, and the next state, and flip flop inputs. Flip flop inputs also we have to find out. Okay, for certain inputs, what will be the output? Okay, like this. Let us suppose present states are like A and B. I am taking. Listen carefully. Okay, let us suppose present state is of flip flop A and flip flop B, and the next state of flip flop A and flip flop B. And what are the flip flop inputs? For example, A is one flip flop, B is one flip flop. For a flip flop A, we will have two inputs, that is a JA and KA. For a flip flop B, we will have two inputs, that is a JB and KB. That is a JB and KB. Okay, just for a time being, I will just remove my image. Please listen carefully. So this is the table which is indicating how the changes will occur. So as I told you, okay. So we have to take these JK flip flops. That's why two inputs I am taking for every flip flop. And this is the present state, and this is the next state. So usually, if the present state is 0 0, okay. So what should be the next state when the count is enabled? So we have to go for 0 1. 0 1. If the present state is 0 1, if the count is enabled, you have to go for 1 0. If the present state is 1 0, if the count is enabled, we have to go for 1 1. If the present state is 1 1, we have to go for next state as 0 0. Like this, states will change. Yes, Darshan Patil, good evening. Okay, so like this, we have to keep on changing the states. I hope you are following, right? So now, for example, if the present state is 0 0, what should be the next state? 0 1. If the present state is 0 1, what should be the next state? 1 0. If the present state is 1 0, what should be the next state? 1 1. If a present state is 1 1, what should be the next state? 0 0. That's all. Now you can just have a excitation table of JK flip flop here so that you can get easily. Are you following? So you can take JK flip flop or you can take T flip flop. You can also do with the T flip flops. Okay. You can also do this with the T flip flops also. Okay. So in that case, T flip flop only easily we can do that. Okay. So now we are moving from the present state is 0 and next state is 0. So 0 0 means what are the possibilities? 0 0 means either we are moving from 0 to 0 means, so either it should be clear to 0, so that is a set reset, or it may be no change. No change means 0 0. So it is a 0 don't care. So 0 don't care. So it is moving from 0 to 1. 0 to 1 means maybe complementing 1 1 is possibility and set to 1. Set to 1 means 1 0. So this is nothing but 1 don't care. 1 don't care. Now 1 to 1. What do you mean by 1 to 1? 1 to 1 means no change. No change is one possibility and set to 1. Okay, so it's a don't care 0. Don't care 0. And 1 0. 1 0 is nothing but it's a clear to 0 and complementing. Clear to 0 means 0 1. Complementing means 1 1. So this is a don't care 1. Like this. Okay. Similarly, JBKB. So 0 to 1 case. 0 to 1 case, 1 don't care. Already we have discussed this. And 0 to 0. 0 to 0 means it's a 0 don't care. Okay. And what about this? No. Actually, we are moving from 1 to 0, right? We have to check the flip flop B. We have to check the flip flop B, sorry. So what is the flip flop B? JBKB inputs. So 0 to 1. So 0 to 1 is nothing but 1 don't care, that is fine. Next here we are moving from 1 to 0. For 1 to 0 case, you should go for don't care 1. Don't care 1. Okay. Now 0 to 1. 0 to 1 means what you have to take? 1 don't care. And 1 to 0. What is 1 to 0? 1 to 0 you can just refer the JK flip flop. 1 to 0 for the JK flip flop. What is 1 to 0? Don't care 1. It is a don't care 1. 1 to 0 don't care 1. 1 to 0 don't care 1. 0 to 1. 0 to 1. 1 don't care. Yes. Got it correct. 0 to 1. 1 don't care. 0 to 1. 1 don't care. That's all. So now we have to get the equation for JA and equation for JB. Equation for JA. Equation for JB. Okay. And it's so then we have to construct a logic diagram for this. I think I hope you can do this. Okay, what you can do is we have to get an equation for JA, input equation, and we have to get equation for KA, and you have to get the logic diagram. So meanwhile, I will also explain to you one more with the help of T flip flop also. Logic circuit using T flip flop also I will explain so that you can understand well. Using T flip flops. So you can finish that JK flip flop. I will do with the T flip flop also, same up counting. Okay, so that we can quickly finish. I think that you can do that. Okay, so now let us suppose I am taking like this. For example, present state is AB and next state is also just next state is AB, and what is a T input? So T input is nothing but what is a TA and TB. Here itself I will do that so that you can understand very clearly. So this is the procedure actually. So after flip flop inputs are known, then what inputs you are giving for the circuit you can understand. So that the table we can give, the logic circuit we can give. For example, I am taking present state is 0 0. Next state should be 0 1. If the present state is 0 1, next state should be 1 0. If the present state is 1 0, next state should be 1 1. If a present state is 1 1, next state should be 0 0. So TA input, when T is changing from A is changing from 0 to 0, TA input should be 0. 0 to 1 means complemented, toggle, TA input should be 1. 1 to 1 means TA input should be 0. And 1 to 0 means TA input should be 1. And 0 to 1 means it is a toggle, so TB should be 1. 1 to 0, toggle, TB should be 1. And 0 to 1, toggle, again it is 1. 1 to 0, again it is toggle. And what is equation for TA? TA is producing 1 in two cases, this one and this one. So that is A bar B plus this one AB. A bar B plus AB. Am I right? So A bar B plus AB is nothing but we can take B as common. So A bar plus A of B. So that is nothing but it is a B. So TA should be equal to B. Similarly, what is the TB value? All are ones means directly we can keep 1. Okay. Now I am going to give a logic circuit using T flip flops for the up counter. You can just watch here. Every one of you, please. This is important. Okay. So now I am taking logic circuit here using the T flip flop. So just for making you to understand both the cases, I am explaining the diagram very simplified manner for the T flip flop. Okay. So that is a TA and that is a TB, and both are connected to the common clock. Okay. So clock is synchronous here. So clock is common for both, and both will be affected at the same time. And this is a flip flop A, and I am taking this as a flip flop B. And this is a present state, and this is a complemented state. This is a present state, and this is a complemented state. Okay. Now coming to what should be given for the TA. TA should be given directly B. What is mean by B? Present state of the flip flop B. I am giving for this. Okay. And what should be given for TB? Directly input 1 should be given. It is always at logic 1. Now one example I will tell you. Let us suppose if a TA and TB contents are 0 0, what should be the next state? So this is 0, this is 0 for example. And 0 we are connecting here as a T input. 0 we are connecting here. Am I right? And a TB input 1 I am connecting. Okay, 0 0. What should be the next state? 0 1, right? Okay. So here AB I am taking A as a MSB, B as LSB. So this is 1, and we are giving 0 here. That means it will be 0. TA will be 0. Okay. And a TB will be 1. So what is the next state when the TA input 0 0? What is the next state when TB input is 1? It is a complement 1. So that means 0 0 state become 0 1. So this is called synthesis of this sequential circuit. Hope you are understanding. Every one of you, please like the channel and like the class if you are really liking it. Don't forget that, and subscribe to the channel, and you can just share with your friends. Okay. So this is a logic circuit for the T flip flop for the up counter. Hope you are understood. Similarly, we can finish the logic circuit for the JK flip flop also. So one and don't care, don't care. So wherever it is, we can consider don't cares as ones. And for each JA, KA, JB, KB and input equations, you can apply, and you can draw the logic diagram like this. Okay. So now coming to the next one more example. Let us suppose one more example. Let us suppose I wanted to get a states like this. For example, 0 3 0 3 1 2 and repeat. This type of sequences are also possible to design a sequential circuit. Let us suppose I wanted to design using the T flip flops, just for instance. Okay, T flip flops. So if the present state is 0 0, next state should be 1 1. It's a 3. If the present state is 1 1, next state should be 1. If the present state is 1, next state should be 2, means 1 0. Again, we have to go back to this. Like this it will go. Okay. So present and the next. Present state and the next state. And inputs. What are the flip-flop inputs? TA and TB. So we are taking two flip-flops A and B. Okay. So TA is a flip-flop inputs for the flip-flop A. TB is a flip-flop input for flip-flop B. Okay. Now I am giving you the table. So based on this, you can design the circuit. The same page I will show you. So present state of A and B. Present state of A and B. Next state of A and B. And flip-flop inputs. If the present state is 0, that means 0 0. So what should be the next state? 1 1. If the present state is 1 1, Okay, I hope you are understanding. Present state is 1 1, next state should be 1, so that is a 0 1. If the present state is 0 1, next state should be 2, means 1 0. If the present state is 1 0, next state should be 0, that means 0 0. So what are the T inputs? You know the flip-flop T criteria, right? So when you're moving from 0 to 1, that means toggle. So this is 1. So 1 to 0, toggle, this is 1. And 0 to 1, toggle, it is 1. And 1 to 0, toggle, it is 1. TB, 0 to 1, toggle, it is 1. And 1 to 1, it is a 0. And 1 to 0, toggle. And 0 to 0, no change, means 0. So now from this TA input is what? So TA is equal to all are ones means it is 1. TB is equal to there are two ones here. One is for 0 0 0 1. 0 0 means A bar B bar plus 0 1 means A bar B. I can take A bar as common. A bar of B bar plus B. So this is nothing but A bar only. So TB is equal to A bar. TB is equal to A bar. So now I will give the diagram. You can just check the same page. So how to give the diagram here? I have to take two flip-flops. A is MSB and B is LSB. So flip-flop A, so that is a MSB, most significant bit flip-flop in the counter. Okay, 2-bit counter. And flip-flop B is a LSB, least significant bit. And both are connected to the common clock as I told you. Okay, you can check here. So this is a clock. Okay, hope you are understanding. Okay, now this is a present state and this is a complemented state. So this is the present state of B and complemented state of B, and we have to give TA input here. We have to give TB input here. Am I right? So what TA input you can give? What TB input you can give? So what is the TA? TA is equal to 1. So we have to maintain TA at logic 1, and TB we have to maintain at A bar. So A bar means the complemented flip flop. Complemented state of flip flop should be connected. That's all. So for certain value, for example, if we have 0 0, you should go to 1 1, right? So I will take that. If the present state of the flip flops are 0 0, let us suppose, next state should be 1 1. How it is? What is the 0 complement? 1 is connected here. Anyway, it is 1. So when the T input is 1, the next state will be complement of the present state. So this is 1. This is also 1. So after 0 0, so we are getting the 1 1. That's all. Okay, is it clear? So that's all about the flip-flops design. Okay, design of counters using the flip-flop. You can also design with other flip-flops also. And as far as the resistors are concerned, we can do with the D flip-flops. Okay, so I hope you understood it. And if you have any doubt, you could ask me now. Is it clear? I hope everything is clear for you. Okay, now coming to before concluding the session, so let me introduce some of the courses offered at Gate Grade Up. Just a moment. So at Grade Up, we are offering multiple courses for computer science in the GATE. One is the Gear Up course. Just a moment. One is the Gear Up at 2021. It is targeting, and Rank Up is targeted for 2021, and the Vision is course for 2022 GATE. So right now, the Gear Up we are offering it is 300 plus hours of live classes, 3000 plus practice questions, 40 plus mock test, and 75 plus chapter wise study notes. Okay. So this is basically Gear Up course is for the concept building, and it is ideal for the students who wanted to revise the entire GATE syllabus once from the fundamentals. Okay. And Rank Up course is also the short term for the 2021 GATE. It's a more emphasis on the problem solving. It is a score improvement program. Here we are offering 300 plus hours of live classes, 3000 plus practice questions, and also 40 plus mock tests and 75 plus chapter wise study notes. So this is ideal for the repeaters who wanted to improve the GATE score, okay, and wanted to get a better score in future. Then better you take the Rank Up. So more 70% of emphasis on the problem solving. Tough problems will be solved. Okay, and Vision course that is 2022. It is a long-term program for 22 GATE, and here 550 plus hours of live classes, 5000 plus practice questions will be there, 100 plus mock test, and chapter 100 plus chapter wise study notes. It is ideal for second and third year students of engineering, because all the core subjects will start from the second year. Better you join from second year, so that by the time you come to the final year, you will, or third year, you can crack the gate exam. So the advantage of having this gate coaching for computer science is you can crack the ISRO computer science, BAR computer science, NILIT, and also DRDO, and other PSU examinations you can get through the gate score. So right now, these four companies like ISRO, BARC, and NILIT, DRDO, they're conducting their own examinations right now, but on the based on the gate pattern only, gate syllabus only. Okay. So to get access to all these courses, better you go through the GradeUp Super subscription. So on multiple the rates it is there based on the duration of subscription. I will explain you at the end. Okay. If you have any doubts related to these courses, you can reach us at 96500 And as far as the faculty are concerned, right now we are having four faculty members. One is myself. I'm having 20 plus years of experience, and Satyanarayan sir is having 13 plus years of experience, and Ankit Doila sir is having 8 plus years of teaching experience, and Navaneet Gupta sir is having 7 plus years of teaching experience. You can interact with these faculty members if you join any of these courses. And coming to this achievers of grade up in the year 2020 for the GATE examination and also engineering services examination. Okay, so more than 60 students of grade up are in top 100. Okay, so for the 2020 GATE exam, and out of that, in computer science, we are having 4th rank, 20th rank, two people of 39th rank, and also 47th rank. And 2018, we got all India top rank for the engineering service examination. Okay. So then in 2019, two mechanical students got all India 10th rank and 27th rank. So let us congratulate to all these grade up achievers. It's a big achievement, and I wish every one of you be in this list in future. Okay. I hope you will join any of the course and achieve these ranks for the 2021 gate. Okay, now coming to the Grade Up Super, you can say Grade Up Super is a one-stop solution for all your preparation needs. Okay, once if you join the subscription to the Grade Up Super, you will get all the structured live courses with India's best faculty of engineering services, GATE and PSU, and complete doubt resolution is there instantaneously, and full coverage of syllabus based on your examination pattern. And as a part of the green card, we are having online mock tests, and these mock tests are designed by the toppers based on the examination, and based on the latest pattern of exam questions are designed. You can reach us at 96500 if you have any doubts related to these courses. Okay, so that's all about the Grade Up Super. Okay, now coming to the rates of the fee for the subscription for the Grade Up Super subscription. Okay, what you have to do is you have to go to the mobile phone and open the Play Store and download the GradeUp app, and you can get the information related how to get a subscription here. For a 3 month subscription, you have to pay 9,000 rupees for 12 month subscription, 22,200 you have to pay for 18 months, and 30,600 for 24 months, 36,000 you have to pay. Okay, so in total, I think this is for 2 years, this is for 1.5 year, this is for 1 year, and this is for 1 quarter, 3 months only. Okay, if you have any doubts, you can reach us at 96500 or you can also mail us at help@gradeup.com. I hope you have enjoyed the session. So I think it's a time to wind up. I wish every one of you happy Christmas. So thank you one and all for your presence. Okay, and please try to attend all the classes and you try to follow me. I have forwarded the link in the chat box. Okay, so try to get full advantage of this. Okay, and subscribe to this Grade Up Super for unlimited access of structural live courses and markets. So that's all about for today. So thank you so much. Thank you one and all. Have a good night. Go grade up, prepare smart, score better, and stay safe. Thank you. Thank you one and all. Have a good night.